So in this exercise, we have two concentric circular low coil X and Y of radii 16 centimeter. So I write R X is equal to 16 centimeter and RY is equal to 10 centimeter. Lies in the same vertical plane containing the north to south direction. Coil X has number of turns, so I write Nx is 20 and Ny is 16. Oh, sorry, Ny is not 16, Ny 25. Ix is the 16 ampere and Iy is 18 ampere. The sense of the current in X is anti-clockwise and clockwise in Y. For the observer looking at the coil facing west, this is very important. West, a person is looking toward the west, so X current anti-clockwise and in Y it is clockwise. So first I try to draw the picture. First thing, both the coils are in vertical plane. So this is suppose vertical plane. Okay, this is the vertical plane. Same vertical plane. So radius are different. So first I draw one X coil. So this is, I say, X, and you have another one Y. This is Y. Okay, and this side is north and this side is south. So this side is east and that side is, sorry, just oh, so this side you have east and that other side you have west. Understood? So looking from south, a person is looking this side, west side. So current in X is anti-clockwise direction. So anti-clockwise means in this direction. So this is the direction of current, and here it is clockwise. For an observer looking at the coil facing west, give the magnitude direction of the net magnetic field due to the coil at their center. So what is the magnetic field here? So first I focus on X coil. So magnetic field at the center of coil X, Bx I say, is mu 0 and I both are X divided by 2rx. So we substitute all this value, 4 pi into number of turns 20, current is 16 ampere, and 2 and radius is 16 centimeter converted into meter. So 16 will cancel out, minus 2, so is still minus 10 to minus 7 is there. So we get this 16 cancelled, so I get 2 to 10, 1 0, 4 pi into 10 raised to minus 4 Tesla. So this is the magnetic field because of x. Now what is the direction? So if you rotate your screw in this direction, or you rotate your fingers of right hand in this direction, the thumb is coming out from this, so toward the west east side, આ બાજુ આવશે. So this is the direction of x. સમજમાં આવ્યું? So this is in west east direction, in east direction. Now we calculate magnetic field of y. Magnetic field of coil y at its center. I think you missed that, right? The center. Yes, it is written. So it is by is equal to mu 0 n y I y upon 2 r y. So again we put all this value, 4 pi into 10 raised to minus 7 into ny. So ny is 25, iy is 18 divided by 2 into ry. So ry is 10 centimeters, it is 0.1. So you will get 9 pi into 10 raised to minus 4 Tesla. Now again we see the direction. So now screw you have to rotate like this, or you have to hold your hand finger this direction, thumb is going inside. So this is the direction of by. Understood? You rotate the screw, it will go inside. So સામેની સાઈડમાં જશે, તો સામેની સાઈડમાં આ રીતે. So this is by. So both are in opposite direction. So in west direction. In west direction. Okay. So here you can see that by is greater than bx. So I take subtraction of by minus bx. So net magnetic field at the center I write b is equal to by minus bx. So 9 pi minus 4 pi. I take common into 10 raised to minus 4. So this is 5 pi into 10 raised to minus 4 Tesla. And this is positive, and this is west side, this is east side, and it is positive. So finally it is in west direction. If we have taken x minus by, then you will get negative. So opposite to the bx, and again becomes west side. So this is your answer. Okay, so it's very important to see the direction. So next one, a magnetic field of 100 Gauss is required, which is uniform in a region of linear dimension about 10 centimeter and area of cross section 10 raised to minus 3 meters square. The maximum current carrying capacity of a given coil is 15 ampere and number of turns per unit length that can be wound is 1000 turns. Suggests some appropriate design, particular of solenoid. તો આનો એક આન્સર ન આવી શકે. You can answer in different way. પણ શું કહેવા માંગે છે કે તમારે એક જગ્યા જોઈએ છે, એરિયા, ત્યાં આટલું મેગ્નેટિક ફિલ્ડ મળવું જોઈએ 100 ગોસ. So we use solenoid. So this is our solenoid. We don't know what is the length, so we will fix the length so that we get, I don't know what is the length. Okay, but it is required that in some length 10 centimeter round, this is 10 centimeter, this is 10 centimeter, where we need magnetic field. How much? Okay, I need 100 Gauss, or you can say that 100 into 10 raised to minus 4 Tesla. Okay, so how we can design? So here current capacity is 15 ampere. So you cannot apply current more than 15 ampere. Okay, and second one, N must be 1000 per meter. So I cannot wound more than this turns in 1 meter. That is my second condition. And મારે એટલું ફીલ્ડ જોઈએ છે. તો કેવું મારું સોલેનોઇડ હોવું જોઈએ એવી આપણે વાત કરી છે. So first thing, to get the magnetic field uniform, you have to use long solenoid. But compared to this length must be very large. તો આપણે એની વિચાર કરીએ. So we have formula B is equal to mu 0 small ni, and therefore Ni is equal to B upon mu 0. mu is 100 in B is equal to 100 into 10 raised to minus 4 divided by 4 pi into 10 raised to minus 7. So if you simplify this, then you will get around 8,000. You are getting around 8,000. So 8,000 upon આવે છે Ni. So Ni is equal to 8,000. Understood? Okay. So how we can manage to get this 8,000? This is our basic. I should have Ni is equal to 8,000. So what should the value of N and what is the value of I? So I can apply current up to 15 ampere. I can apply 8 ampere, તો number of turns વધી જશે. પણ કેટલા વધવા ન જોઈએ? તો એ તમને લિમિટ આપેલી છે કે 1000 ટર્ન્સ થી વધવા જોઈએ નહીં. કોઈ એમ કે હું 1 ampere આપું. Suppose I take મારે 1 ampere જ આપવું છે. So if I is 1 ampere, then N becomes 8,000 turns per meter. But it is not allowed because 1000 is the maximum capacity. So if I take 2 ampere, then this becomes 4,000. It is also not in, it also overcomes our limit. So એક એવો idea લઉં કે 10 ampere. Okay, I take 10 ampere. The number of turns becomes 800 per meter. Now it will work. 800 less than 1000 and 10 ampere is less than 15. કોઈ એમ કે મારે I is equal to 80 ampere લેવો છે, તો number of turns કેટલા થઈ જાય? 100. તો આ 80 થઈ જાય, આ number of turns વધી જાય, પણ આ વધી જાય છે, તો આ બી ન ચાલે. So this will not work, this will not work, this will work. આ સિવાય બી બીજી possibility છે. તો number of turns મારે એટલા જોઈએ છે. So we can think I take a solenoid of 50 centimeter અને એમાં ટર્ન હું લઈ લો 400 tons. Okay, so it will work 50 centimeter 400 tons and 1 meter it becomes 800. It will work. બરાબર 50 centimeter. If this is long solenoid, we use the formula of the long solenoid. તો 50 ની કમ્પેરિઝનમાં diameter મારે નાનો રાખવો પડશે. So I keep suppose diameter is equal to 2 centimeter. It will work. 2 centimeter is very less than the 50 centimeter. અને એના વચ્ચેનો એરિયા મારે જોઈએ છે એટલો ભાગ છે 1. So I see what is the area. If this is 2 centimeter, just I take this side calculation. A is equal to 3.14 into 2 into 10 raised to minus 2 square. Okay, તો કેટલા થઈ જાય? So this is 3.14 into 4 into 10 raised to minus 4. So almost this is 12 into 10 raised to minus 4. So this is 1.2 into 10 raised to minus 4. Okay, so this is the meter square. Just to take the idea. આટલો એરિયા છે આનો. જો if I take radius is 2 centimeter, yes. તો આપણે કેટલા એરિયામાં જોઈએ છે યુનિફોર્મ? તો કે 10 raised to minus 3, so it will work. It will work. You will get uniform. કારણ કે એરિયા આનાથી તો વધારે રાખવું પડશે ને, તો તે નહીં તો આ એરિયા વધારે હોય અને આ નાનું બનાવીએ, it will not work. તો મારું I can use diameter, not diameter, but radius is 2 centimeter. It will work. So I use a solenoid of 50 centimeter long with 400 tons. Radius is 2 centimeter and current is equal to 10 ampere. Other combination also possible. આનો એમ બી પૂછી શકાય કે નીચેનામાંથી કયું ચાલશે એવું. Question may be asked like that. If we need this much field, then which of the combination will give this much field? તો તમારે ABCD options માંથી select કરવાના થાય. એ ટાઈપનો ક્વેશ્ચન આમાંથી બનાવી શકાય. Okay. Then next. A toroid has a core non-ferromagnetic of inner radius 25 cm and outer radius 26 cm around with 3500 tons. So total number of tons is 3500. R1 is 25 cm and R2 is 26 cm. So I convert into meter into 10 raised to minus 2 meter. And current is 11 ampere. Then what is the magnetic field outside? So you know the construction of the toroid. So I roughly draw in speed માં દોરું છું થોડું. તો આવું આપણે toroid હોય તો અહીંયા આગળ કેટલું magnetic field? We know this is 0, here also 0. અહીંયા કેટલું હોય આપણે કેલ્ક્યુલેટ કરવાનું. જરૂર નથી બતાવવાની. Here also 0, here also 0. We discuss in theory part also. So magnetic field inside toroid B equal to mu 0 small n I. So mu 0 total number of tons upon I divided by circumference 2 pi r. Okay, what is r? So it is r1 plus r2 by 2. So here r is equal to r1 plus r2 by 2. So it is 25.5 into 10 raised to minus 2 meter. Okay. So we substitute all this value. Mu 0 4 pi into 10 raised to minus 7. Number of turns कितना आपल्याला आता 3500. What is the current? 11 divided by 2 pi into radius is 2.5 into 10 raised to minus 2. So if you simplify it, 2 pi is cancelled over here. Here also minus 2 is going up. So finally you will get around 3 into this is 3 into 10 raised to actually 3.02 into 10 raised to minus 2 Tesla. So this is the magnetic field inside the toroid. So this is your answer. Okay.